Hello guys, how are you? This is the algorithms once again, and I'm sorry for not publishing any more PowerPoints, and I'm so sorry for not removing this one too, because this is part of my school, and to be honest I was tired to remove it, so all the credits go to my school. Big up for that school. So let's begin with chapter 1. We're going to begin with analog digital representations. Don't worry, I've covered this before, so I'll give you some brief information on it and I will help you even more. We'll go some advanced drawbacks, analog to digital, digital to analog, blah blah blah. We're going to begin with basic characteristics of binary number system. Later on, with the next PowerPoint, we're going to give it BCD, binary coded decimal, which is really cool. We're going to define typical digital signals and time diagram. Differences between parallel and serial transmission, major parts of this computer, their functions, of course, property of memory, and distinguish among microcomputers, microprocessors, and microcontrollers. Sorry about this guys, but my city where I live is in the middle of this worst city ever, in the worst country. Bear with me because I will go through window. Sorry about that guys. So let's find the typical digital signals, different between parallel and serial, major parts of digital computer, their functions, properties of memory, distinguish among microcomputers, microprocessors and microcontrollers. So let's begin with. We have a large part of worldwide communication system, which falls in the category of digital system. It started as a simple digital system that used only two states to represent information, 1 and 0, also on and off, as you know. And this is a telegraph, you can see here, with a battery called key and telegraph wire, which will directly to click a route, and later on get to another one, so you can say receiver. A telegraph system consists of a battery of a code key, a normally open momentary context switch, a telegraph wire, and electromagnetic clocker. The telegraph system used two distinct symbols, which just mean any word or number, short and long electrical pulses, dots and dashes of Morse code. A digital representation of information. The electric signal is either on or off at all times. This relates to a modern digital system that uses electrical signals to represent ones and zeros. A time diagram shows which state 1 or 0 the system is at any point, and shows the time when a change in state occurs. We have the battery voltage and the key press, and later on we have some ground key release. We have the dash and dots here. As you can see here, it goes over 0 to 0.8. If we have 0.8 means 0. If we have 0.8 until 2, it means we have an error. If we have 2 to 5, it means 1. Don't worry, I'll cover that too, it's cool. We have a physical system with quantities which must be manipulated arithmetically. The quantities may be presented numerically in either analog or digital form. Analog representation is a continuously variable, a proportional indicator. Sound through a microphone causes voltage changes. Oh, I forgot. Microphone here, the school microphone. So I guess now you hear me better, I think. I don't know, sorry about that. I'll check again if there any problem. I'll do it once again, no problem. No, it was here, yeah. We have an analog presentation, a continuously variable, proportion indicator, sound through a microphone causes voltage changes. Automobile speedometer changes with speed. Mercury thermometer varies over a range of values with temperature. I saw the sound through a microphone and I thought to give you an example. You see what happened? How did it change the voltage? This is because the voltage changes. I'm pretty sure you might hear the difference now. In 1875, Alexander Graham Bell figured how to change his voice in a continuously variable electrical signal. Send it through a wire and change it back to sound energy at the other end. Today the device that converts sound energy to analog voltage signal is known as a microphone. We have some meme here. Mr. Watson, come here. Like he wasn't there at all. Like, come on, mate. We have the digital representation with various in discrete separate steps. We have passing time is shown as a change in the display on a digital clock at 1 minute intervals. A change in temperature is shown on digital display only when the temperature changes at least 1 degree. The digital system, a combination of devices that manipulate values represented in the digital form. We have the analog system, a combination of devices that manipulate values represented in an analog form. We have the advantages of digital. It is easy to design, well suited for storing information, accuracy and precision are easy to maintain. We have programmable operation, of course, less affected by noise, ease of fabrication IC chips. I'm so sorry about that. Maybe. Okay, guys, just if you notice one, just carry on really fast, no problem. IC chips. Blah, 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 blah. Integrated circuit chips, sorry. I'm so sorry. It is integrated circuit chips. It means easier fabrication integrated circuit chips. There are limits to digital techniques, of course. This is one of the drawbacks. We cannot convert them all because the analog nature of the world requires the time-consuming conversion process. So, yes. We can convert the physical variable to an electrical signal form. This kind of limited to do that. The convert the signal to digital form, process operate on the digital information, and then convert the digital output back to the real world analog form. The digital system is a combination of devices designed to manipulate logical information or physical quantities represented in a digital form, and the quantities can take on only discrete values. An analog system manipulates physical quantities represented in analog form, and the quantities can vary over a continuous range of values. We have the party line callers encoded a person ID by the way they crank their telephone. The signaling rings use a digital representation, but voice communication was pure in analog. You see that? The representation. The rotary dial phone uses a series of pulses representing the 10 decimal digits. In touch-tone phones, digital switch information is sent using analog tone signals. Yes, what they said, all we represented right now in the 19th century or in the 20th century, I think, it was done all in one part called the cell phone. The cell phone has digital and analog components and uses both types of signals. This is a digital circuit. You can see here more how it works. You see it is camera up and down, LCD screen, and the speaker. You can see here the microphone is located, but it's here directly, not here. So my school is fault. Why have they done like this? Come on, mate. The microphone is directly here, guys. Okay, don't listen what they say. Here and the keypad. Come on, you know. This is the command, and this is directly converting the ASCII values there. The temperature regulation system using analog to digital converter. As you see, this is thermostat. It uses digital processing, and it will go directly to digital analog conversion, and later on it controls the heat. And the heat has some sensors. We know all the heaters have some sensors, and they directly go to analog digital conversion. Analog digital conversion are really important because they can tell you and convert and let you know how things are with the sensors, what it's doing right now, what's been going on with it, etc. Everything. That's why the sensor and analog digital conversion are really important, and because the sensor it senses the heat there, and it changes some signals with bits. Sometimes with ASCII values. It only depends by the type of what analog you have, but most of them are binary. I've seen some in my school, which is my ASCII, but okay, it's the same though. They do the same job. We have the analog digital conversion. The analog to digital conversion goes directly to the digital signal representing the actual temperature. Then it goes to digital processors. Sometimes the digital processor will give some input here and change directly.
but this is done automatically if we want to programmable be. That's why it is easy to design, guys. We have some chief reason toward the shift to digital technology. Digital systems are generally easy to design. Information storage is easy. Accuracy and precision are easy to maintain throughout the system. Operations can be programmed. Digital circuits are less affected by noise. More digital circuitry can be fabricated on integrated circuit chips. And there have been remarkable recent advances in technology. Blah blah blah. Continue digital. Okay. Understanding digital system requires understanding decimal binary octal. As we have covered before, decimal is 10, binary 2, octal 8. Okay, the hexadecimal is 16, of course. Decimal 10, hexadecimal is 16, octal 8, binary 2. We know this one, we have covered all the way from the first course I've done. The decimal base 10 system, 10 symbols, 0 to 9. Each number is a digit from Latin, blah blah blah. You don't need this one, don't worry. You are a programmer, not literature. Of course, you can do this one. The binary based system, we have two symbols 0 and 1. It lends itself to electronic circuit design since only two different voltage levels are required, 0 and 1s. Position value may be stated digit multiplied by the power of 2 to the power of 0 to the power of 1 to the power of 3, blah blah blah, etc. But of course, in this case, we've done to the negative power over 3, 1 over 8, 1 fourth, 1 over 0.5, 1 half, and then 0, 1, 2, 3, 4, etc. Here we have the weights. To the power 3 is 8, to the power 2 is 4, and now it's got done by binary. Also, later, I don't know if this presentation has, we're gonna go with a gray code, which is represented only when the values of bits are changed rapidly, which is really cool. And then we'll do some illustration there to illustrate to you guys. We have the analog signals can be converted to digital by taking measurement of samples of the continuously varying signal at regular intervals. Appropriate time between the samples depends on the maximum rate of change of analog signal. Air temperature is an analog quantity. Recorded samples are discrete integer data. Yes, you can see here, typical representation of the two states of digital signal. Yes, we came right when I started to say about it as well. A higher range of voltages represent a valid 1, and a lower range of voltages represent a valid 0. High and low are often used to describe the states of digital systems instead of 0 and 1, 1 and 0. As you can see here, if we go to 0 to 0.8, don't forget this one, okay? 0 to 0.8, we have 0 here. If we have 0.8 volt to 2 volts, it means invalid voltages. These are not used at all. If we have the circuit of our system goes to 0.8 volt to 2 volt, it means, or to 2 volt, one of these inside here, it means we have an error. We have invalid voltages, it doesn't work. If it goes 2 to upper to 5, 2 to 5 volts, it means that it is 1 on them, We have two-state devices, as I said before, light bulb off and on, diode, conductor and redundant, relay energized or not energized, transistor cutoff and saturation, photocell illuminator dark, blah blah blah. The oscilloscope and logic analyzer are used to produce timing diagrams. Timing diagrams show voltages versus time. It is used to show how digital signals change with time or to compare two or more digital signals. 0, 1, 0, 1, so you can see here, blah, up, down, up, down, up, down. A horizontal scale represents a regular interval starting at time 0. Digital circuits produce and respond to predefined voltage ranges. The term logic circuit is used interchangeably. A digital circuit responds to an input's binary level of 0 and 1, not to its actual voltage. We have the parallel transmission. All bits in a binary number are transmitted simultaneously. A separate line is required for each bit, of course. This is the old way, and I don't like this one too, don't worry. And we're gonna go directly here with a serial transmission. Each bit in a binary number is transmitted per some time interval. Least significant bit to the most significant bit here. The parallel transmission is faster but requires more path. The serial is slower but requires a single path. It only depends on you, but I would choose, I don't know, serial maybe. But parallel is fast, I don't know. Whatever you like, parallel or serial, it does the same job. It receives and sends. A circuit which retains a response, but okay. if it is faster parallel, but if you go with the LAN local area network, if you check that briefly, the RJ45 the ports, the female and male part, it is some like like fields there like this, like a red, green, or blue. Do you remember this one? Orange, like that. Yeah, maybe I don't know. Yes, but blah blah blah. A circuit which rotates the response to momentary input is display memory. The memory is important because it provides a way to store binary numbers temporarily or permanently. We have the non-memory circuit. It goes 0 1 0 0 1 0. We have the memory circuit. It goes 0 1 0. It goes like 0 1. The memory elements, magnetic optical electronic latching circuits. A computer is a system of hardware that performs arithmetic operations, manipulates data, and makes decisions. It performs operation based on instruction in the form of a program at high speed and with a high degree of accuracy. With the major parts of a computer, its input in unit processes instruction data into the memory. Memory unit stores data instruction. Control unit interprets instructions, sends appropriate signals to other unit as instructed. Arithmetic or logic unit, arithmetic calculation and logical decision are performed. Output unit, it presents information from the memory to the operator process. So let's see how it goes. Data information goes to input. The input would go to arithmetic LEU or to memory. It goes directly to channel CC unit here. Then by the info that gets from memory to control, it goes to its output, and also to LEU arithmetic logic unit goes to output too. And that information, as you can see here, it controls the input output directly with the control signals. We have some types of computers. Okay, this is important. This is a basic important part, guys. So you should know this one. Okay, don't embarrass me. Types of computer with microcomputer, most common discovered RPCs, has become very powerful mini computer workstation. Mainframe, microcontroller, designed for a specific application in dedicated or embedded controllers. It is used in appliances, manufacturing processes, auto ignition system, ABS systems, and many other applications. And the basic function of digital subsystem of a cell phone, other embedded applications are controlled by a complete microcomputer system embedded in each phone. Of course, when you take a picture to the phone, converts the brightness of individual spots into CCD to binary numbers and stores it in memory, a row X, column X, in a matrix form. Let's check the illustration later, ABC. So, as you can see there, it is really easy to compute it. And let me do some quick check about CCD here. CCD is a charge coupled device. It is like integrated circuit too, but it has an array, as I said, array or matrix. Circuit charge devices, charge coupled devices to binary numbers. It goes to the camera, measure pixel brightness columns. Blah blah blah. Yeah, it's done. Displaying the image of LCD screen is the reverse process of storing the image in memory. When we speak in the phone, the voice signal is converted to string digital binary numbers, and signals get separated and routed to the proper place by digital multiplexer and demultiplexers. There are many needs in the world that digital technology can meet. We will be able to become one of the pioneers on these new frontiers of technology. I hope so. You too, guys. Have a great time. Cheers. Bye bye.